The universe. It's vast, isn't it? Full of wonders. For centuries, we humans have looked up at the stars. We've wondered about our place in this grand cosmic ballet. We build tools, ever more clever, to peer deeper into the darkness. From the simplest spyglass to giant telescopes on mountaintops. Each new tool has peeled back another layer of the cosmic onion, revealing sights that have astonished and inspired us. Now, we stand at the threshold of a new era of discovery. Imagine a thinking machine, but not like the ones we know. This is the dawn of quantum artificial intelligence, or QAI. It's about a new way of processing information, inspired by the strange and wonderful rules of the quantum realm, the world of the very, very small. This QAI is poised to unlock secrets that have remained stubbornly hidden from our traditional methods of inquiry. And what a partner for this new kind of brain, the James Webb Space Telescope, our magnificent eye in the sky. It's out there, far from Earth, gazing into the deepest, oldest parts of the universe. It sees light that has traveled for billions of years to reach us. The JWS is already a marvel, a triumph of human ingenuity, but even its incredible power can be amplified, its discoveries deepened. So what happens when you team up this incredible telescope with this revolutionary new kind of intelligence? You get something extraordinary. Today, on this very day, May 23, 2025, we are talking about such a moment. A moment where the combined might of the James Webb Space Telescope and a cutting-edge quantum AI has uncovered something truly mind-boggling. Let's talk about this incredible machine, the James Webb Space Telescope, or JWST for short. It's not just any telescope, it's a time machine. Floating 1,000,000 miles from Earth, it's perfectly positioned, far from the glare and interference of our own planet. This allows it to capture the faintest whispers of light from the most distant objects imaginable. Its giant golden mirror, a beautiful honeycomb structure, is designed to collect infrared light. Why infrared? Because the universe is expanding. As light from distant galaxies travels towards us, it gets stretched. Red light has longer wavelengths than blue light. So this stretching effect, called redshift, shifts the light from very distant objects towards the infrared end of the spectrum. The JWST is specifically tuned to see this ancient, stretched light that started its journey when the universe was just a baby. The engineering behind the JWST is simply breathtaking. Unfolding that massive sun shield the size of a tennis court in the cold vacuum of space, aligning those 18 hexagonal mirror segments with pinpoint accuracy. It's a testament to human collaboration and ambition. Thousands of scientists and engineers from around the world work together to make this dream a reality. And the images it has sent back, they are nothing short of spectacular. Cosmic cliffs, phantom galaxies, the birth of stars. But the JWST collects more than just pretty pictures, it gathers enormous amounts of data. So, what is this quantum AI, this QAI we've mentioned? It sounds like something straight out of science fiction, doesn't it? And in a way it is. It's the future happening right now. Traditional computers, the ones in your phone or on your desk, think in bits. A bit can be a 0 or it can be a 1, like a light switch. It's either off or it's on. Simple, effective for many things. But the universe, especially at its most fundamental level, isn't always so black and white. Quantum computers, the brains behind quantum AI, don't use bits, they use qubits. A qubit, thanks to a quantum phenomenon called superposition, can be a 0, a 1, or both at the same time. Imagine a spinning coin. While it's spinning, it's neither heads nor tails. It's in a state of both possibilities. This ability to exist in multiple states at once allows quantum computers to explore a vast number of possibilities simultaneously. It's like having millions of paths to explore, all at the same instant. Quantum AI uses these quantum principles to tackle problems that are impossibly complex for even the most powerful classical supercomputers. Problems like designing new materials atom by atom, or discovering new medicines, or, as we're discussing today, sifting through colossal amounts of cosmic data to find patterns that are incredibly subtle. Patterns that might signal something entirely new about the universe. It's a new kind of intuition powered by the laws of quantum mechanics. How does a quantum AI actually think or process information? It's quite different from our everyday computers. As we said, classical computers use bits, zeros, and ones. They follow instructions step by step, one calculation after another. Very logical, very linear. But for some problems, this step-by-step approach is just too slow. Imagine trying to find your way through an enormous maze with billions of possible paths. A classical computer might try each path one by one. A quantum AI using qubits can explore many of these paths at the same time. Thanks to superposition, each qubit represents multiple values simultaneously. With just 300 qubits, a quantum computer could, in theory, represent more states than there are atoms in the observable universe. This parallel processing power is what gives QAI its incredible advantage for certain types of problems. Then there's entanglement. This is where qubits become interconnected. The state of one qubit can instantly influence the state of another, no matter the distance separating them. This interconnectedness allows quantum algorithms to perform complex calculations and find correlations in data that are deeply hidden. Section 5. Cosmic Mysteries. What is a singularity rift? Now let's get to the heart of today's incredible news. The quantum AI, working with data from the James Webb Space Telescope, has detected something called a singularity rift. What on Earth, or rather what in the universe is that? Well, it's a concept that pushes the boundaries of our current understanding of physics. It's not something you'll find in standard textbooks, not yet anyway. This discovery might just write a whole new chapter, or perhaps even a whole new book. First, let's talk about singularities. We usually encounter this term when we discuss black holes. At the center of a black hole, our theories predict a point of infinite density, where all the matter that has fallen into the black hole is crushed into an infinitely small space. A point where the known laws of physics, like Einstein's theory of general relativity, break down. That's a singularity. Section 6. The unthinkable found. Spotting a rift in spacetime. The idea of a singularity rift has been, for the most part, theoretical, a playground for imaginative physicists. Few believed we would find direct evidence of such a thing in our lifetimes. The universe is good at keeping its most profound secrets. It doesn't give them up easily. To even conceive of searching for such a rift requires a leap of faith, a willingness to look for something that our current models of the universe don't fully predict or accommodate. It means sifting through unimaginable quantities of data from the James Webb Space Telescope, looking for tiny deviations, for whispers of the unexpected, a task far beyond human capability, and even beyond the reach of our fastest conventional supercomputers. This is precisely where the power of quantum AI comes into its own. The QAI wasn't told to find a singularity rift. It was tasked with analyzing the JWST's deep field observations, looking for anomalies, for patterns that didn't fit established models. The QAI, with its ability to process information in a quantum parallel fashion, could assess correlations and subtle gravitational lensing effects, or unusual energy signatures, on a scale and with a sensitivity previously unattainable. And it found one, a significant one. Section 7. The Moment of Revelation. How Webb and QAI did it. So, how did this astonishing discovery unfold? The James Webb Space Telescope conducted ultra-deep field surveys capturing light from the earliest galaxies. Terabytes of data were fed into the quantum AI system. The QAI built a complex model, looking for outliers. It flagged an area with distorted light suggesting a singularity rift. Section 8. Why this changes everything. The impact of the rift. The discovery of a singularity rift is not just another interesting astronomical finding, it's a game changer. It's one of those moments in science that fundamentally alters our perception of reality. Think of Copernicus realizing the Earth orbits the Sun, or Einstein revealing the interconnectedness of space and time. This has that kind of potential. It challenges our most fundamental theories about the universe, particularly general relativity, and our understanding of singularities. It tells us there's more to the cosmic story. For decades, physicists have been trying to reconcile general relativity, the theory of the very large, with quantum mechanics, the theory of the very small. Section 9. Beyond the Horizon, Humanity's Next Cosmic Chapter. This discovery, born from the marriage of the James Webb Space Telescope's keen sight and the quantum AI's profound insight, marks the beginning of a new chapter in our cosmic journey. We stand on the shore of a vast, unexplored ocean of knowledge. The Singularity Rift is like the first glimpse of a new continent full of unknown wonders and challenges. What will we find as we explore it further? What other secrets does the universe hold, waiting for the right tools and the right minds to uncover them? The synergy between advanced observational instruments like the JWST and powerful analytical tools like quantum AI is clearly the way forward. Imagine future telescopes even more powerful, coupled with even more sophisticated QAIs. What might they reveal? Perhaps we'll map the large-scale structure of these rifts, understand their origins in the primordial universe, or even detect subtle influences they might have on the distribution of dark matter and dark energy, those other great cosmic mysteries. The possibilities are truly exhilarating to consider. This isn't just about abstract knowledge. Understanding the fundamental nature of space-time, of singularities, could eventually lead to breakthroughs we can't yet imagine. New sources of energy, new ways to understand gravity, it's too early to say. But history teaches us that fundamental scientific discoveries always eventually transform our world in unexpected ways. The journey of discovery is a long one, but its rewards can reshape civilization itself, often for the better, expanding our capabilities and our horizons.